All right, let's try to prove this following inverse Laplace transform formula. All right, here it is. Inverse Laplace transform of s over quantity s squared plus k squared squared is equal to 1 over 2k times t sine of kt. All right, so I'm going to start with letting f of t equals t sine of kt. By taking a derivative, we get f prime of t is equal to sine of kt plus kt cosine of kt. Simple product rule. And then you take another derivative. So f double prime of t comes out to be 2k cosine of kt minus k squared t sine of kt. Right? By taking the Laplace transform of the second derivative, we're going to get this, right? So if you take the Laplace transform of the f double prime, you get s squared Laplace transform of f of t, which is t sine of kt, minus s times f of 0 minus f prime of 0, which is equal to, right, if you take the Laplace transform of the right-hand side, so 2k, pull it out, and Laplace transform cosine of kt is s over s squared plus k squared, minus, pull out the k squared here, we have a Laplace transform of t sine of kt. And you notice that the same thing showing up here. Right, so before that, we know that f of 0, right? So if you plug in 0 here, you can see that f of 0. So we can actually scratch that out, right? How about f prime of 0? So if you plug in 0, so sine of 0 is 0, 0 times anything is 0. So f prime of 0 is also 0, so we can scratch that out, right? Then you can bring negative k squared Laplace transform t sine of kt over to the other side. We're going to get quantity s squared plus k squared times Laplace transform of t sine of kt is equal to, what's left is 2k times s over s squared plus k squared, right? Then we can divide through by s squared plus k squared and also divide through by 2k. We're going to get this, right? Laplace transform of, so you divide by 2k, so you have a 2k on the bottom. I put it inside the Laplace transform, t sine of kt. And then you divide this guy by s squared plus k squared, so you have the quantity s squared plus k squared squared, right? And then by taking the inverse Laplace transform both sides, we're going to get inverse Laplace transform of s over quantity s squared plus k squared squared is equal to 1 over 2k t sine of kt, which is the desired result. All right, that's it. I hope that this was clear.